Okay, today we'll have a presentation by group, okay, on the project. So at first you have to identify the problem and take a case study, and you have to use the advanced analytical model. So try to get the data sets and provide detailed solution using deep learning techniques in artificial neural network. Okay, and then you have to provide step by step on how data being analyzed with deep learning, right? You can use this guide as a cross-industry standard process for data mining, where you can use for your project, alright? And today we will have a project presentation with the project leader and the group members. Okay, thank you.
Hi, Assalamualaikum. My name is Muhammad Alikbal Nur Hakimi. I'm the leader of Group F, and my metric number is B03231056. And I'm going to represent that our project, which is handwritten number recognition using CNN. This is the rest of my groups. We are 5 people that are doing this project. And for the introduction, our project, which is accurate handwritten number recognition, is vital in areas like postal sorting and check processing to boost efficiency and reduce errors. This project addresses the challenges using convolutional neural network, which is CNN, which excel in visual tasks by learning special patterns. And by using the MINIS dataset of 70,000 labeled 28 times 28 grayscale images, we train and evaluate a deep learning model with TensorFlow and Keras. Following the CRISP-DM methodology, the result demonstrate the effectiveness of CNN in real-world digit classification and forms a basics for future OCR applications. Next, I'm going to pass to my other teammates.
Assalamualaikum and hi, my name is Mohammed Ijaz Ahmad and I will continue the presentation with results and finding. So as we can see, the model went through 5 epochs, and through the 5 epochs, the training accuracy improved from 84.65 to 97.61. The training loss dropped from 0.5106 to 0.078, and the validation accuracy increased from 96.82 to 97.87. Validation loss is reduced from 0.1219 to 0.0701. And the test accuracy is 0.9897. This is the graph of epoch and accuracy. As we can see, the accuracy increased a lot from the 0 epoch to the first epoch. So the next part is testing model. Okay. Through the testing model, it plots the model sees the number as this after the pre-processing and model testing performance. The trained model was evaluated on 10,000 test images from the dataset. It achieved high accuracy, showing strong generalization to unseen data, which shows that the model doesn't show any sign of overfitting. The model can accurately recognize and predict handwritten digits 0 to 9 across diverse writing styles. This confirms that the CNN learned meaningful patterns and features during trade. That's all from me. Thank you.
Okay, so Assalamualaikum. My name is Alif Iskandar and I will continue the presentation for the flowchart, how the process in the code starts. So it starts by first loading the MNIST dataset that will be used to train the model. But first, we load the dataset into the code, and the code will pre-process the image data. After the image data has been pre-processed, that's when the CNN model will be built. During this process is when we split it into a training set and testing set, and we pick the technique such as deep learning, and after that that's when we start training the model. So after training the model, the model's performance will be evaluated. So after the evaluation of the performance, the interface for drawing your own handwritten numbers will be launched using HTML canvas. So using this interface, that's where a user can input their own handwritten numbers into the HTML canvas interface. After user have input their own handwritten number, the image will be pre-processed. After being pre-processed, using our own model, using our CNN model, our model will predict the user's number that is inputted into the interface, and after that it will display the result of the recognition. So after that is the learning process. So the learning process occurred is the CNN model learns to recognize digits using 60,000 label examples. The label examples are from the dataset, the MNIST datasets, using a supervised learning. And after that, the images are normalized and label are one hot encoded for effective training. During the training, the model improves through backpropagation over 5 training cycles or epochs. And then a validation split ensure learning is accurate and avoids overfitting of the datasets. And finally, the final model gets to predict the new handwritten digits of the users through a live interactive interface, which is the HTML interface. So that's all for me. We'll continue with the results and finding.
Okay, for next part, I will explaining about deep learning function. So I just give you a summary to it. First thing first, we're gonna do load dataset. Use the MNIST dataset with 7,700 grayscale image of handwritten digits. Then split into 60,000 for training and 10,000 for testing. Loaded via TensorFlow for easy access. So the second one is pre-processing and visualization. So this will normalize pixel value to 0 to 1 and reshape image to fit CNN input format. Labels were one hot encoder for multi-class classification. So the next one is we're gonna build a CNN model. Use Keras Sequential API to build the model. The first one is conv2d plus max pooling layers for feature extraction. Then we're gonna use flatten plus dense layers for classification. Dropout added to prevent overfitting. And the last one, we're gonna softmax the output layer to predict digit probabilities. Okay, next one, we're gonna compile the model using the ADA optimizer and categorical cross-entropy loss function, tracking accuracy asymmetry. Then after we compile, we're gonna train the model over 5 epochs with 20% validation split to monitor generalization, and the model will improve steady. Learning digit patterns will be efficiently. So the last one is we're gonna evaluate model. Okay, tested on unseen 10,000 images, and we will get the achieve high accuracy, that is 98%, showing excellent generalization and recognition ability. Okay, next one is dataset. Okay, our project use the MNIST dataset with 70,000 grayscale images of handwritten digits. There is 38 uh, darab with 38 pixels. So, including 16,000 training and 10,000 testing images, we will label it from 0 to 9 only. As you can see on the right, figure to the right, we have label file 0, 2, and 1. Okay, that is the example lah. So the next one, image will be normalized and labels are one hot encoded for CNN processing. So this will be easily into accessible via TensorFlow, Keras without manual download. Then the last one, we could enable the model to learn and generalize digit patterns for real-time user input.
Hello, Assalamualaikum Doktor. I am Muhammad Muiz bin Samsudin, which have number metric of B0323104550. So for my presentation, I will answer for the Q&A session. The question is, how can this be useful for the future of our community? It is because this project has practical applications in education, accessibility, and also automations. Education, it will help students in learning how to do handwriting recognition basics or test their drawing clarity. For accessibility, it could aid visually impaired users by converting handwritten digits to audio or like a vibration, something like that. And for the automation, it will streamline tasks like processing handwritten forms, for example, survey or checks. So for the future potential, it will expansions to letter or symbols. It will be adaptable for broader character recognition like a lesson plate and also postal codes. Integrate for future integration with apps. It will embeddable in educational apps or IoT devices such as smart whiteboards. So it is not just a demo, it's a step toward to solving real world digit recognition challenge. So for the second question, why do we use CNN method instead of others? We use CNN methods because the performance is proven. The CNNs that we use, it will excel at image tasks like MNIST digit recognition, which achieving in more than 98% accuracy. So the efficiency, it is lightweight enough for real-time predictions in deployed environment such as Google Colab. For the scalability, the same architecture can be extended to more complex such as multi-digit recognition. And then as for the comparison to other models like SVMs or random forest, they are struggle with pixel level spatial features. For the pre-trained models like ResNet, they are too overkill for simple digits and actually slower to deploy than CNNs. So this model offers the best balance of accuracy, speed, and actually adaptability for our specific use case. That's all for me. Thank you, Doctor.
Hello, it's me again. So this is our part of the demo. This is our full code. So we are I already run all of this line of codes. So this is our data set that we load, and then we normalize the data. After that, we build the CNN model using Keras, and then we train. So we use 5 epochs, and we created a drawing interface using HTML. This all of this line of codes. Then we will get this part. So as you can see, we can draw any number from 0 to 9. So for example, I'll choose number 2. Then we recognize. Then the AI will predict it, and the confidence is through 1 and below. So let's say it doesn't really confidence, and it will just put like 0.98 or 0.81 or something if it doesn't have that kind of confidence. So we can also clear it again, and we can also draw it again. So I'll choose 6, and like for example like this. So it cannot fully predict yet, but most of the time it will predict correct. So let's try again with 9. So yeah, it doesn't fully confidence, but the model itself predicted right. So like 1, 8. So and then cut. So and then we let's say we choose 7. Cut. Bodoh lah. Okay, for example, we draw again. Let's say we choose 3, for example. So here, the model itself like confidently 100% it's 3. So that's all for our project. Thank you for listening and goodbye.